Today I want to talk about a solution that me and my partner Naveta created for the StackUp 2026 hackathon for KeenStack. We are the dot walkers and we created a solution called Keystone. Keystone is a AI powered operations layer that sits right on top of ServiceNow's existing CMDB operations. And its purpose is to streamline the workflows that engineers and administrators already use to monitor, regulate, and improve their CMDB. So a CMDB rarely becomes unreliable because of one major failure. Problems actually build gradually, and this is where data comes from discovery tools, cloud platforms, integrations, and manual processes. Each source might follow a different standard. So that means over time, duplicates will appear, relationships will go missing, ownerships become unclear, and IRE rules may no longer work as expected. And this is something that engineers right now can see, but investigating them across different records, tools, and processes just take a lot of time. This is where we connect Keystone. Keystone connects that work through a model called CPR. It's meant to comprehend the environment, prioritize the work that will make the greatest differences, then support controlled remediation through ServiceNow IRE. Keystone is not here to replace any existing CMDB workflow. It's here to bring them together and automate the repetitive work and help engineers focus on the decisions that require their expertise. From a technical perspective, Keystone works between the source data and the CMDB. Data can come from files, APIs, cloud platform, discovery tools, or existing ServiceNow records. Keystone will move that data through the CPR model, where it can comprehend the environment, prioritize the necessary work, and then prepare the appropriate remediation. So before any production change is made, the records are actually validated against ServiceNow's live IRE rules. ServiceNow will then determine whether each record should create a new CI, update an existing one, or require further review. So Keystone serves as the orchestrator, while ServiceNow continues to govern every production change. The intention with this is seeing how we can get engineers 80% of the way there through their typical CMDB operations by automating the repetitive investigation and preparation that an engineer might regularly do. We want to improve the accuracy by detecting problems earlier and validating changes before they actually reach your CMDB. And overall, we want to make sure that with any scaling system, we want to provide as much low risk to be automated, while higher impact decisions remain under a human in the loop decision making. So let's move on to see how this actually works in ServiceNow. So here inside ServiceNow, Keystone has its own application and supporting navigation. Before entering the live application, I want to briefly introduce the agents behind it. So at the center of it all, we have an agent orchestrator called Mara. Mara is our primary orchestrator that manages the CPR workflow and coordinates 5 specialized subagents. Each one focuses on a different area of CDB operations, including data quality, duplicates, relationships, ownerships, and IRE behavior. By working together, we can connect issues that would normally be investigated separately, such as what does a duplicate record problem look like when it comes from an inconsistent source? Or how do we handle problems that have an IRE rule that is no longer working as intended? Mara will come in and bring these findings together, determine the next steps for you, and present the work through one connected experience. So now let's actually move into the live application and see that process in action. So this is the Keystone workspace where the full CPR workflow will actually take place. So let's move into the control plane where it will land us inside of the intake stage where you take in your source data and stage it for Mara to execute the workflow. For this demonstration, I'll be using a dataset that consists of 600 CIs. So once the data is staged, What's happening is Mara and her specialist agents are identifying the records, analyzing their conditions, and connecting issues that would normally require separate investigations. So rather than giving a team like another list of errors, Keystone can actually build context around what's happening and show why. After that, Mara will organize the affected CIs into work groups and recommend actions the team can take. So it does this by first showing you what your health score is for this particular data set. And out of the CIs that were problematic, it separated those CIs into work groups, and it will immediately show you what are the tasks that you can do right now and how much of a health lift would it give you right now to your current CMDB. If we were to do all 4 of these, we would raise our current CMDB health from 88% to a projected 97%. There's also a case that you might have some preventative tasks that may show no immediate health lift, but they still strengthen your data integrity and prevent the same problems from continuing. After that, we move into the remediation layer. So inside of the remediation layer, it follows a 4-step process where we separate all of the CIs that were problematic into their own batches, and we simulate them against ServiceNow's live IRE rules. This will determine which records are actually eligible to proceed onto ServiceNow, and then which ones still require attention. And the way to do that is fairly simple through a step-by-step process where you will go ahead and plan the campaign and simulate the current eligible CMDBs into its own particular group. And what's going to happen is we will go ahead and plan the packet approval where it will group all of these CIs into its own data set. And in the case that we are fine with what Keystone has provided for us, we can immediately fill in this demo hash where we would authorize this packet flow to move into ServiceNow. And as you can see right here, we can actually commit these CIs to ServiceNow right now. This is intentional to where we are handling each like a batch of CIs 100 by 100 just to ensure that there is no connection issue. We don't want to make sure that we're not overloading the servers by sending in thousands and thousands of CIs at once. So we just handle it in batches. But sometimes that might be repetitive and you might want this to be more automated. This is where we have an autonomous mode for Mara, where if there are any approved CIs that are ready to go back into ServiceNow, we can utilize an autonomous mode. So if I go ahead and start this right now, you'll see right here in this agent queue, it's going to go ahead and drain the queue by doing the exact same process that I just showcased earlier, where we planned the campaign packet, simulated all eligible CIs against ServiceNow's IRE, and then grouped them up into batches to send off to ServiceNow. So after it lands in ServiceNow, we can go ahead and show you what our new health lift is looking at. So it finished that. Let's go back to the agent workspace. So it was able to move 384 CIs back into ServiceNow. And what you can see is we started off with a baseline health of 88%. And of the 384 out of 600 that we moved into ServiceNow, it was able to bring our current CDB dataset health score to 94%, which means the remaining CIs that were problematic would give us an additional 3% after remediating it manually. So now we can go back to ServiceNow where we can see the results reflected in the CMDB. We created a dashboard that brings all of the activity together, showing what Keystone processed, how those changes affected the environment, and just showing how we can give administrators a clear record of what changed without requiring them to trace the process across multiple tables. And we can also monitor how Keystone uses AI across the workflow through this AI usage page. Not every task requires the same level of reasoning, so I assigned models based on task complexity. So routines tasks such as classification, formatting, or basic validation will use smaller models, while more complex tasks such as connecting the findings, analyzing relationships, or determining remediations will use stronger models only when that additional reasoning is needed. This reduces unnecessary token usage while preserving performance for the tasks that matter most. And this is to make a Keystone operationally effective and cost efficient as usages scale. So to bring everything back to CPR, Keystone comprehends the CMDB by connecting the data, its conditions, and the processes affecting it. We prioritize the work by showing teams which issues need attention and which actions can make the greatest differences. And we remediate these through controlled automations with every production change governed by ServiceNow. So we want to make sure that Keystone actually brings these existing CMDB workflows together so engineers can spend less time investigating and more time improving their environment. Thank you.